Hello viewers, in this video I will be discussing about logarithms and anti-logarithms. Now under this we will see the properties of logarithms, then what are natural and common logarithms, standard form of a decimal number, then what is characteristic and mantissa, the steps to find the logarithm of a number, how to use logarithm tables, what are anti-logarithms, and how to use anti-logarithm tables. Here we will see a few properties of a logarithm. Logarithms are always defined only for positive real numbers and positive bases different from 1. So, if you take any logarithmic value log m to the base a, both m and a are positive. That is, the given number and the base both are positive. On the other hand, the logarithmic value can be negative. Say for example, log 10 raised to minus 2 to the base 10 is equal to minus. So, this value can be negative, whereas the given number and the base can never be negative, they are always positive. The next property is log 1 to any base is 0. We have discussed about this in the previous video itself. So, log 1 to any base is 0. And the next property is log of 0 is not defined. This we have to be very careful. You have to remember this, log of 0 is not at all defined. Usually logarithms, under logarithms we have two types, one is natural logarithms and the other one is common logarithms. Those logarithms which are written to the base e are called natural logarithm. E is, the value of E is 2.718281. In our calculations and in our common practices, we use common logarithms. These common logarithms are written to the base 10. We will see some more about this common logarithm. As I already mentioned, common logarithms are written to the base 10. The reason being, we usually use the decimal number system. Under this decimal number system, we use the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and use all these 10 numbers while writing any number in our decimal number system, and all these numbers are written to the base 10. So, that is why we usually use common logarithms for our calculations. While using this common logarithm, we have to express the given number as product of an integral power of 10 and a number between 1 and 10. Say for example, let us take this number 583. We can write 583 as 5.83 into 10 raised to 2. So, this is what is given. We have to express the given number. Here the given number is 583. I am writing this 583 as product of an integral power of 10. This is the integral power of 10, 10 raised to 2. This is the integral power of 10 and a number between 1 and 10. This is the number between 1 and 10. So, this is how we have to write a given number while using this common logarithms. So, this is called the standard form of a decimal number. So, the standard form of a decimal number n is equal to m into 10 raised to p. The value of m lies between 1 and 10. So, we can write any decimal number in this form. We can even write fractions. Say for example, we can also write 0.0021 as 2.1 into 10 raised to minus 3. Our p is minus 3, p is equal to minus 3 and m is equal to 2.1. So, even you can also write even a number like 0.0021 as 2.1 into 10 raised to minus 3. The next one is, what is characteristic and mantissa? When we express any decimal number in the form n is equal to m into 10 raised to p, when we take log on both sides, we get log n is equal to log of m into 10 raised to p. Writing it here, log n is equal to log of m into 10 raised to p. This is equal to log m plus log 10 raised to p. This is equal to log m plus p log 10. Log 10 is 1. So, it is equal to p plus log m. This p is called the characteristic and this log m is called the mantissa. The mantissa is usually in the form of a fraction and have p as integer. So, this is called characteristic and mantissa. Now, let us see the case when the number is more than 1, when the given number is more than 1. We have few results. We know that 10 raised to 0 is equal to 1, 10 raised to 1 is equal to 10, 10 raised to 2 is equal to 100, 10 raised to 3 is equal to 1000. So, we have log 1 equal to 0, log 10 is equal to 1, log 100 is equal to 2, log 1000 is equal to 3. All these are to the base 10. So, on seeing these, log 1 is equal to 0, log 10 is equal to 1, log 100 is equal to 2, log 1000 is equal to 3, up to etc. On seeing this, we can note one important point, that is, when the given number is between 1 and 10, the given number is a single digit number, then the value of log is between 0 and 1. When the given number is between 10 and 100, that is when the given number is of 2 digits, then the value of log is between 1 and 2. When the given number is between 100 and 1000, that is if it is a 3 digit number, then the value of log is between 2 and 3. So, how to find the characteristic of a number? In general, we can either write the given number in the standard form. If we find it difficult to write the given number in the standard form, we can find the characteristic using this property. Here we have, in general, for a number n containing r digits in the integral part, the characteristic is equal to r minus 1. Let us consider a number 422. Here the integral part contains 3 digits. So, the characteristic of this number is this 3 minus 1, it is equal to 2. Let us consider another number 52.33. Here the integer part contains 2 digits. So, the characteristic is two minus 1 is equal to 1, that is this p is 2 in case of 422 and it is equal to 1 in the case of 52.33. So, this is how we can find the characteristic either directly from the number, or we can also write this 422 as 4.22 into 10 raised to 2. So, automatically our p is 2 here. Similarly, this 52.33 also can write it as 5.233 into 10 raised to 1. So, characteristic is, so this is how we can either do it directly, or we can write the given number in the standard form and then from there we can find the characteristic. The next one we will see when the number is less than 1. So, again similarly we have few results. We have 10 raised to minus 1 is equal to 1 by 10, 0.1, 10 raised to minus 2 is equal to 1 by 100, 0.01, 10 raised to minus 3 is 1 by 1000, 0.001. So, what is? We already know log 1 is 0, then log 0.1 is minus 1, log 0.01 is minus 2, log 0.001 is minus 3. So, similar to the case where we found characteristic when the number is greater than 1, when the number is less than 1, if the number is between 1 and 0.1, if the number is between 1 and 0.1, the value of log is between 0 and minus 1. When the given number is between 0.1 and 0.01, value of log is between minus 1 and minus 2, and so on. So, in general, for a given number n which is less than 1, the characteristic is negative and it is equal to 1 plus number of zeros after the decimal place. So, usually we denote this characteristic with a bar on the figure. Now, let us take an example. Take 0.03. Here the number of zeros after the decimal place is 1. So, characteristic is negative and it is 1 plus the number of zeros after the decimal place, it is minus 2, but we denote it as bar 2. Is that clear? I hope this is clear. Next one is, let us take another example, 0.0041. Here there are 2 zeros. So, characteristic is bar 3. Or we can also express this in the standard form. 0.023 is equal to 2.3 into 10 raised to. So, again from here also I am getting P as minus 0.0041 is 4.1 into 10 raised to minus 3. From here I am as. So, do not write minus 3, we have to write bar 2 and bar 3. Why we are writing bar 2 and bar 3 is because it is only the characteristic that is negative and this log m is not negative. This Mantissa part is not negative, characteristic negative. So, hence we are writing bar 2, bar 3 and I hope this is clear. Next one we will see how to use logarithmic tables find the log of a number. So, the first step is we have to write the given number n in the standard form. The next step is we have to find the characteristic. Then the third step is we have to look for log m from the logarithmic tables, and then fourth step we can write log n is equal to p plus log m. So, this is how a log table will look like. The first column has got numbers from 10 to 99. It has got two pages. The first column has got numbers from 10 to 49, and in the second page it continues with 50 to 99. Then we have the next 10 columns are numbers from 0 to 9, and then we have another separate column which has the mean difference and it has numbers from 1, 2, 3 up to etc. Now we will see an example as to how we can use the log table to find the log of the given number. So the question says find log 2.145. So if you remember the steps I already told you, the first step is we have to write the given number in the standard form. So here it is log 2.145 to the base 10. So the given number is 2.145 is equal to 2.145 into 10 raised to 0. So we have to write it in the standard form, that is our m should be between 1 and 10 into 10 raised to p. This p is called the characteristic and this log of this number is called the mantissa. So log of 2.145, we have to take the first two digits 21. So we have to locate where 21 is the first column. So the row corresponding to 21 is here. Then the next digit is 4. We have to see under column number 4, row number 21. This is column number 4 under row number 21. So it is 3304. So the value corresponding to row 21 and column 4 is 3304. Then we have to add the mean difference corresponding to the next digit 5. So in the same row, the mean difference corresponding to 5 is 10. So plus 10. So the answer is 3314. So the value of log 2.145 is, here our characteristic is 0. So 0.3314. I hope this is clear. So we are asked to find log of 2.145. We have to express this 2.145 in the standard form. So it can be written as 2.145 into 10 raised to 0. So our characteristic is 0 and mantissa is log of 2.145. So we have to take the first two digits and check the corresponding row. So our first two digit is 21. So we have to see the row corresponding to 21 and column corresponding to the next digit, which is 4. So the number is 3304. So we got 3304. Then the mean difference corresponding to the same 21 row is 10. Here we got 10. We have to add that mean difference to the number which we already got. So on adding 10 to 3304, I get 3314. So log of 2.145 is 0.3314. The next question, we have a few questions. Find log of 21.45. So previously we saw log of 2.145. Here it is log of 21.45. We can either write it in the standard form, 21.45 is equal to 2.145 into 10 raised to 1, and we can write the characteristic as 1 plus the mantissa is log of 2.145, or we can use the property of finding the characteristic. Here the integer part has 2 digits. So the characteristic will be 2 minus 1, that is 1. So this is equal to 1 point log of 2.145. So again I am seeing row number 21, the first two digits 21, row number 21 under column number 4. So it is 3304 3304, adding the mean difference in the same row. The mean difference of the, you have to take the next digit, that is 5. Mean difference 5 corresponding to 21 is 10. Adding it, I get 3314. So here the value of log 21.45 is 1.3314. Whereas in the previous question we saw log 2.145 is 0.3314. Here log 21.45 is 1.3314. The next one is B part. Find log of 0.001352. So here we can either write it in the standard form and then find the characteristic, or we can directly write the characteristic. The characteristic will come with a bar sign, and it is 1 plus number of zeros after the decimal point. So the number of zeros after the decimal point is 2. So it is 1 plus 2, which is 3. So the characteristic is bar 3 plus log of 1.35. This is the Mantissa. So this is equal to 1.3 log of 1.352. We have to take the first 2 digits and look into that row. So here this is the row number 13. The next digit is 5 and look into column 5. So this is the row. Looking into column 5, so I get 1303. The mean difference in the same row is the next digit is 2. So the mean difference corresponding to in the same row 13 is 6. 1303 plus 6, 1309. So the answer is bar 3.1309. Here only this 3 is negative, whereas this 0.1309 is positive. This the Mantissa part is positive. The next question, see, find log of 0.1884. So here there is no 0 next to the decimal point. So the characteristic will be negative plus 1, that is 0 plus 1, which is negative 1 or bar 1. So bar 1 plus log of 1.884. So this is equal to bar 1. Here log 1.884, the first 2 digit 18. So we have to take row number 18 and column number 8. So it is 2742. 2742. The mean difference corresponding to 4 is 9. So when we add, we get 2751. So the answer for log 0.1884 is bar 1.2751. So this is how we can find the value of log of a number using log tables. All these values are to the base 10. The next one we have anti-logarithms. If log n is equal to x, then n is equal to anti-log of x. When we have log of a given number, then we can find the given number by taking anti-log of the answer. So here we have log n is equal to x, means n is equal to anti-log of x. Now what are the steps to find the anti-log? In the given log n, we have to take the Mantissa and we have to make sure it is positive. Then we have to use the anti-log tables to find the anti-log of the Mantissa alone. Let us say it is r. Then using the characteristic p of log n, we can convert it to the standard form as n is equal to r into 10 raised to p. It is just the reverse of how we do for logarithm. In logarithms, we will first write this standard form and then we will find the log of that number. Here we will first take the mantissa, then find its antilog, and then we convert it into the form. So this is how the antilog table look like. It is similar to the log table except that it starts with 0 and then it continues as 0.01, 0.02 up to etc. 0.49, then 0.5, 0.51 up to etc. 0.99. It also has another few columns for the to calculate the third digit, and then it also has the mean difference column which we have to add, similar to the log table. Now we will see a few problems. The first one, find x if log x is equal to 2.7758. So we have to verify first whether our mantissa is positive or not. So our mantissa is positive. So if log x is equal to 2.7758, then x is equal to antilog of 2.7758. Now we have to take this mantissa part alone, that is we have to take 0.7758 alone and then we have to find the antilog. So now antilog of 0.7758, here we have 0.77 and then we have to see the next digit is 5. So look into the fifth column. So here the number is 5957. The next digit is 8. This we have to look into the mean difference column. This is the mean difference column and the number corresponding to 8 is 11. So we have to add these two, we get 5968. So the antilog of 0.7758 is antilog of 0.7758 is 5.968. So x is equal to antilog of 2.7758. So here this mantissa part, antilog of this mantissa part is 5.968 into, we have to write it in the standard form, into 10 raised to the characteristic of the given log number. So that is 10 raised to 2. So the characteristic is 2. So the value of x is 5.968 into 100. So it is 596.8. So this is how we have to find the antilog of a number when, so that we can find the number x. So log of the number is given. You can find the given number by using antilog tables. The next one, find x if log x is equal to minus 2.2357. So here it is given log x is equal to minus 2.2357. It is not given bar 2.2357. Here it means the mantissa is negative, that is log x is equal to minus 2 minus 0.2357. Here, since the mantissa is negative, we have to make it as a positive number. To make it as a positive number, I am subtracting and adding 1, that is minus 2 minus 1 plus 1 minus 0.357. So, here this minus 2 and minus 1 gives minus 3 plus 1 minus 0.2357. I am doing this to make this mantissa positive. So, here 1 minus 0.2357, the answer is 0.7643. So, this is bar 3.7643. So, here I am writing bar 3 because only this 3 is negative and 0.7643 is positive. Now, I can find the antilog. So, x is equal to antilog of 0.7643 into 10 raised to minus 3. So, antilog of 0.7643 into 10 raised to, so this is equal to 0.76 is here, and then the next digit is 4. So, I have to see the column number 4, it is 5808. 5808. Then I have to add the mean difference under column number 3 because the next digit is 3. So, the mean difference is 4. So, the answer is 5812. So, antilog of 0.7643 is 5.812 into 10 raised to minus. This is equal to 5.812 into 1 by 1000. This is equal to 0.0058. So, this is the antilog. So, when log x is minus 2.2357, x is equal to 0.005812. I hope this is clear. I hope this video was useful for you. In my next video, I will be discussing about simple applications of logarithm and anti-logarithm. Thank you for watching.